my name is Marco Abela, and I'm part of the Dell EMC Storage Product Management Division. Here today, I will talk to you about running virtualized applications inside a modern storage platform using Dell EMC PowerStore AppsON. PowerStore is the next generation mid-range offering from Dell EMC that is built from the ground up for NVMe. Its design principles are centered around three main themes. The first is data centricity, with the ability to run any workload, whether physical or virtual, block-based, file-based, or container-based, in a performance-optimized appliance designed for NVMe that can scale up in single drive increments as well as scale out, all with always-on inline data reduction. Next is intelligence, with a programmable infrastructure that enables DevOps and automation through integrations such as VRO and Ansible. PowerStore also has built-in AI and ML, which simplifies typical storage administration tasks, such as optimizing system resources, and also uses it to provide proactive health analytics to reduce risk by predicting potential future issues and needs. Last is adaptability, with a flexible container-based architecture that can be deployed as a traditional external storage array or with Vmware's ESXi hypervisor integrated to allow virtualized applications to run directly on PowerStore. This offers flexible deployment models to modernize infrastructure regardless of location and provides choice, predictability, and investment protection through flexible consumption models and data-in-place upgrades. PowerStore is built around the PowerStore OS, which is a container-based active-active architecture which is optimized for next-generation technologies such as NVMe media, is able to provide multi-dimensional scale with the ability to scale up, scale out, and even scale down, all while providing always-on inline enterprise data services. In following a modern container-based architecture, the PowerStore OS is made up from a group of modular containers, with each container providing a specific service. Examples of running containers in the PowerStore operating system include a container for the control path services, a container for the data path, a container for data mobility, which handles things such as replication, one for serviceability, and even one for file services. This modularity provides two main benefits. The first is the ability to restart and upgrade specific containers without impacting other containers. For example, if a specific library needs to be updated due to a security vulnerability and that library resides in the control path, we can upgrade that specific container without any impact to I/O. Where with the traditional monolithic stack architecture, you would need to take down the entire stack and fail over I/O. Second is the ability to go to market faster with best-of-breed services across Dell technologies. For services that are common across our storage products, rather than have each individual storage product group build their own version of an offering and have it behave completely and have inconsistent experience across the products, we can have a common engineering team that focuses on delivering best-of-breed shared technologies, which when delivered as a container can be easily consumed as part of this architecture, which is exactly what we're doing, for example, with our serviceability and file services. By building PowerStore from scratch, a new data path created around NVMe, we were also able to build new leading data reduction technologies. If you look at the Dell EMC primary storage portfolio today, XtremIO leads in terms of DRR with an average DRR of 3.75 to 1. With PowerStore, our expected DRR is 4 to 1, made possible by having a compression offload and fine granular dedupe that is always on and in memory. And in fact, we are so confident in this that we even guarantee it. Now, PowerStore can be deployed in two primary different deployment models. The first is with a standard traditional deployment model, which is the PowerStore T model, in which PowerStore serves storage to external hosts as a traditional storage array via Fiber Channel and iSCSI. But what's so radically different about this platform is our hypervisor-based deployment, also known as AppsON. Now, if you look at the PowerStore appliance and really think about it, the two nodes that run the PowerStore OS and provide the active-active HA capabilities are really just purpose-built servers with each of the two nodes having dual-socket CPUs in memory. With the AppsON offering in the PowerStore X model, the ESXi hypervisor is loaded onto each of the two nodes, and the PowerStore operating system is running active-active as a VM on each of these two nodes, providing the exact same data services on the exact same hardware. What this allows is local compute to be exposed so that virtual machines can be run directly on the same PowerStore appliance using the same VMware tools to administer this that the majority of companies have already standardized on today. This is ideal for storage-intensive data-hungry applications, OEM solutions, and infrastructure consolidation use cases where PowerStore provides the ability to run applications protected in an active-active HA manner with enterprise data services all in a single 2U appliance. In addition, this deployment model is multi-personality in that apart from allowing applications to run on internal compute, it also simultaneously acts and serves storage to external hosts via fiber channel and iSCSI like a traditional SAN, offering the ability to modernize while protecting existing infrastructure investments. Both of these models, the PowerStore T or the PowerStore X with AppsON, run on the exact same PowerStore hardware, which is fully redundant dual node appliance with each node having dual socket Intel CPUs that can scale from 16 to 56 CPUs per node and 192 gigs of memory to 1.28 terabytes of memory per node. And again, it's two nodes per 2U appliance. In terms of drive support, as the base enclosure of the appliance is all NVMe, supported capacities are 1.92 terabytes all the way up to 15.36 terabyte NVMe drives. And for customers looking for the highest levels of performance, SCM is supported in 375 gig or 750 gig capacity points. Additional drives can also be added via expansion shelves. Now let's look at some deployment scenarios where PowerStore can be utilized to modernize infrastructure starting at the edge. Usually requirements for the edge are low latency, high availability, and small footprints, as these locations don't typically have primary data centers, so space really comes at a premium. PowerStore with AppsON is ideal for these edge site requirements, allowing streaming data from devices to be captured at the edge site with the edge site application running directly on the same appliance for ultra low latency. As mentioned before, PowerStore models support the same core features. PowerStore has built-in native replication, which allows these edge site locations to replicate to a core data center where cross-edge site data can be aggregated and analyzed. And since both models are fully interoperable, the PowerStore X model with AppsON can replicate to a larger PowerStore T model residing in the primary data center. By leveraging the industry-leading ESXi hypervisor, we also automatically inherit some core native services that come as a part of it, such as Vmotion. Using Vmotion, customers can move workloads around from existing external ESX servers onto PowerStore with AppsON as needed, including existing HCI solutions such as VxRail as a complementary extension. And remember, the AppsON model of PowerStore also acts as a traditional SAN in that it also provides storage to external servers, whether bare metal or virtualized via fiber channel and iSCSI. Now let's talk about all the innovation, all the IP that went into the AppsON architecture. So first is through work done as part of a three-way NDA with Intel and Vmware. PowerStore leverages Intel's VMD technology for a direct private PCIe domain, which pass-throughs the ESX hypervisor, enabling bare metal NVMe performance. This also provides full support for NVMe plug-and-play, which enables our fully online single drive scale-up capabilities, as well as supporting PCI fault containment. The second benefit, or the second innovation that went into this architecture, is that we solved around a noisy neighbor problem. The PowerStore OS resources, which are used for serving storage, are completely separated from user space resources, which are used to create and run virtual machines, guaranteeing consistent and predictable storage performance at all times so that no resources are trespassed to the other side. Next is the multi-personality, which I talked about before. The PowerStore X model with AppsON is multi-personality in that apart from allowing VMs to run on the internal nodes, it also simultaneously acts as a traditional SAN array, serving block workloads to external servers via fiber channel and ISOs. These external servers are external ESX servers. Again, you benefit from inheriting native ESXi data services, such as Vmotion, allowing to move workloads around from external ESX servers to the internal ESX servers that make up the PowerStore X model as needed. And next, which we'll talk a little bit more on in the next slide, is a really tight vVol integration that we have spent a lot of time on. So let's spend some time to talk about PowerStore's efficient vVol implementation, which includes some very cool integrations that we have done to give customers the best possible experience with vVols. The first is a turnkey vVol setup. There's nothing to configure. You simply register your vCenter server and PowerStore will take care of the rest, allowing you to use vVols instantly. VASA provider registration, protocol endpoint creation, storage container creation, and even the vVol data store is created automatically. In addition, all data services, such as data reduction services, are fully on and always running on vVols. Next is end-to-end VM visibility, which provides the ability to track capacity utilization, VM compute performance, storage performance, alerting, protection, and display individual vVols that make up a VM. From the PowerStore manager, a user can view all these VMs running and utilizing vVol storage from the PowerStore array. Next is integrations with VMware's Spbm. We currently expose quality of service through Spbm, and we will continue to expose more and more storage policies in the future, such as local protection and replication. And last is integration with managed snapshots. Snapshots can be taken on demand or via a protection policy assigned to a VM from the PowerStore manager, which are then displayed in vCenter, meaning if a snapshot is taken from the PowerStore manager of a vVol-based VM, those snapshots are visible in vCenter by right-clicking a VM and do manage snapshots so that a VMware administrator has access to them as needed. But it's also vice versa. A snapshot taken from VMware via right-clicking a VM and selecting Create Snapshot, those same snapshots are displayed and available in the PowerStore manager. But our VMware integration doesn't stop with vVols and truly is unmatched. In addition to our vVol integration, we also have integration with VRO for automation, along with PowerStore being supported as an external storage array to workload domains under VMware's VCF. Last, I want to display a use case highlighting the power of AppsON in a customer scenario. So an example of PowerStore with AppsON in action is in the healthcare space. Medical informatics offers a suite of applications called SickBay that unlock over 300 data points created by bedside devices, from heart rate monitors to ventilators. All this data is collected at the edge and then both stored and streamed to both local and remote nurses stations where multi-patient monitoring can happen from a centralized location. This requires a solution that can provide ultra-low latency, high storage to store years' worth of patient data, and is easy to use, and provides high availability in the smallest possible footprint because these locations, again, don't have typical primary data centers. Leveraging PowerStore with AppsON, the sickbay application suite can run directly on PowerStore, taking advantage of both local compute and enterprise storage in a single consolidated system. Typically, patient data disappears within 48 to 72 hours, but now leveraging sickbay and PowerStore, data can be kept for much longer so that a trend can be created for each patient to provide new insights. Streaming data can be collected at the edge from bedside devices and placed in front of a physician in real time while ensuring performance and availability in a small footprint. This is the power of AppsON. Thank you very much, and I hope you enjoyed this session.